Hello and welcome to my video, lesson 3.4, applications of quadratic functions. So we're going to look at 4 different questions here, 2 real-life situations, and then 2 where we're looking at the min and max of real-life situations. So let's take a look at the first one. Sally throws a ball off her apartment balcony from a height of 50 meters. If it reaches a maximum height of 55 meters after 0.5 seconds, when will it hit the ground? So basically, we need to think about a few things here. I might have to put some spaces in here to give some room. But basically, we need to think about our vertex form. So we go like this, plus q. And so what we need to know is, first of all, we need to know our p and our q, which are our vertex. Okay, so our first step is to find our vertex. So in this case, it tells us quite straightforwardly here that our maximum height, so our vertex, is this and this. Okay, if you're not sure, seconds are almost always the x. So we're going to have a vertex of 0.5, comma, 55. So what we're going to do is we're going to write that in. So a equals x minus 0.5 squared plus q is 55. And now what we're going to do is we need to find a. So what do we do to find a? Well, what we're going to do is we're going to solve for a by using the value of one of our points. So if we think about our graph in this case, we can look like this, or we can actually zoom in and just look at our positive values. And we can imagine that, maybe I'll use a different color here. We can imagine that it goes up and then it comes down, right? So she starts off at 50 meters, right? It goes all the way up to 55 meters, and that's after 0.5 seconds. This is all that we know so far, but that's enough because with that data, we got our vertex, which is our maximum, 0.5 is 55, and we can get another point. That's this point here, and that's 0, 50. So with those 2 points, we can now put in the 0, 50 for our x. So let's do that right now. So our x and our y, so we have 50 equals a. X is 0, squared plus 55. And yes, we are going to need a little bit more room. So let's do that. So now what we need to do is we need to solve for our a. So we're going to bring the 55 over. We're going to have a negative 5. We're going to have 0.5 squared, which is 0.25. And then we're going to solve for a. So a equals negative 5 over a quarter over 0.25. And so that would be negative, let me just plug that into my calculator here. I guess I can do it right here. So 5 divided by 0.25, so it's 20, negative 20, which is not what I intended it to be, but that's okay. So we have negative 20 here, so that is our a value, and so now all we have to do is rewrite that in. So y equals a, which is negative 20, x minus 0.5 squared plus 55. And that is our function. Now what we can do is we can plug that in as our function. See how much room we can get. We can squeeze out. So we have a negative 20 bracket x minus 0.5 squared plus 55. So now that we have that, we can just graph it. And we can't see it really well right now, but let's go to 0. Let's go to 0. We want bigger height, so let's go to 25. Oh, we're going to actually have to go all the way to 55, aren't we? So let's go to 60. And let's start with this and see if that works. Yeah, it's pretty close. Let's go down to 3. There you go. So now we have ourselves a graph, which is pretty fantastic. When will it hit the ground? Well, we need to find the 0 point. So we're going to go to second function, calc, and we're going to find the 0. Okay, so all the way down here. Enter is our left bound. There's our right bound, and we guess there-ish. And so now it gives us our 0 point is x equals 2.1. I'm going to go 2.16. Not meters, seconds. Alrighty. Fantastic. Okay, so let's take a look at the next question here. We have the arc of a banana can be given by a parabolic function. The banana measures 20 centimeters on top. Let's maybe draw this out. So we have a countertop with the arc facing down. So this is our banana, right? You can imagine that we have a banana. Look how beautiful my banana is. Okay, and so we're just looking at the bottom of our arc. So this part. Okay, pretend it's a perfect arc. The banana measures in at 20 centimeters, so right here is 20 centimeters. And the highest point above, this is clearly not to scale, is here, which it is 2 centimeters above. So now what we can do here, which is quite helpful, is we can draw a straight line up, and we can actually mark that this point is 2 centimeters. All right, so fantastic. We have 2 points, which is all we need. We need the maximum, or the minimum in different cases, and we need another point. And so we have actually 3 points that we could look at. This is 0, 0. Here we have 20, 0. And here we have, this is the tricky one here. We have halfway between, this is 10, so 10, 2. Okay, so with all of that in mind, we're going to put in what we know first, which is that x minus 10 squared plus 2. Okay, so we got the 10 and the 2 from our vertex, right? And then we'll go through and we'll try to find a by using one of our points. Let's use the 0, 0 point. So 0 equals a, 0 minus 10 squared plus 2. Now, to find a, we're going to get a minus 2 on this side, and we'll have negative 10 squared. And so a will equal negative 2 over 100, or negative 1 over 50. Okay, actually I'm going to get rid of that, because let's write it out a proper way one time. So negative 1 over 50, x minus 10 squared plus 2, and that is our equation, which you could write in your calculator and get more information out of, but we are good with that information. Okay, so let's take a look at some min-max problems. These ones are tricky until you kind of get used to them, so let's take a look. 2 positive integers have a difference of 10. So first of all, let's write down our two integers. Our two numbers are going to be a and b. So a minus b equals 10. All right. And so, oh, it might actually have to be a minimum now that I'm thinking about it. One of them will be, no, it should be fine. It should be fine. Okay, so a minus b is 10. Yeah, I might actually have to flip it. And then it says, what if their product is a maximum? So our other equation is a times b, and we'll just call it product. We don't know what it is, but it is something. And so now what we need to do is we need to write one of the letters as the opposite of the other. So what I mean by that is we're going to take this function and we'll go a equals b plus 10. So now what we can do is replace a with b plus 10. So we're going to do that. B plus 10 times b equals product. And I have a feeling like we're going to be a minimum, not a maximum. Yeah, I think we're going to have a minimum. So maybe I have to change that. Okay, so then once we have that written out, so let's clear our original value and go and just type this in. So x bracket x plus 10 bracket, and now we just press graph. Okay, we don't have a lot of room. Actually, this is going to be a really stupid question because it's going to be a minimum if b is 0. What a dumb question. Mr. Drager, why did you make this question? Okay, let's make I wanted to have it different than the question from the workbook or whatever. So from the notes. Okay, that's okay. We're going to do it differently. We're going to do it with a maximum, and we're going to do it with the sum. And so now we're going to get 10 minus b. And so when we plug that in, we'll have b times 10 minus b equals product. Okay, now let's plug it in, because before it was making a really stupid minimum that means nothing to us. But we have it backwards, so 10 minus x. There you go. Graph. Okay, so we are going to have a lot more x values. So let's go to 25 and see if that works. Yep, that works. Let's go down to 15 and see if that works. Okay, yeah, that's fine. All right, so what is the product if it's a maximum? Let's go and try to calculate second function calc down to maximum. We need to find the left bound, so we're just going to go to left of our maximum. Right bound, it says, so you need to go to the right of our maximum, and then we need to guess, so we're going to go kind of roughly at our maximum, and it will give us a maximum of 25. So the product equals 25, okay, based off of what we say here, and it tells us that our x is 5, so it tells us that helpfully that b equals 5, okay, and if a plus b equals 10, and we know b is 5, right, then it's just a plus 5 equals 10, or we know that a will also equal 5. 10 minus 5 is 5. Okay, so kind of weird, but sorry about the minimum thing. I should have checked it before, but it works with maximum. If you have 50 meters of rope from Canadian Tire and you want to form a rectangle. What is the maximum area possible to contain? So similar sort of question, and hopefully you guys have seen the one from the note pack. But basically, we need to make two things. So the perimeter, okay, equals length times 2 plus width times 2, right? Area equals length times width. Okay, so now we have two different problems here, and we know that the maximum perimeter that we can have is 50 based off of the meters of rope, right? So that's the maximum perimeter. So with that in mind, we can now solve for one of the other and put it in as an equation. So let's do that right now. So we can actually straight up simplify this to L plus W equals 25. And then what we can do is get L equals 25 minus W. And so now what we can do is plug that in for our L value. So we get W times 25 minus W, and we're looking for the maximum. So all we have to do now is plug this in. Very similar to the last question, just now 25 instead. And so we graph that, and totally does not fit in our function, so we need to have a bigger height. Probably somewhere around the 175-ish, I would guess. Yeah, close. The height is good, so now we just need to have more. Oh no, that didn't work. So maybe 25? There you go. Perfect. Okay, so what is the maximum area possible to contain? Well, what we need to do is we need to get the maximum. So left bound is somewhere around here. Right bound is somewhere around here. And now we are solving for the maximum. And the maximum is telling us that the maximum area, is 156.25. 156.25 meters squared in this case. All right. I hope that this video helped you understand application of quadratic functions a little bit better, how to make the functions based off of the data or based off the graph, and also how to read the questions a little bit better and find min and max. Hope this video helped. Good luck.